Okay, let's dive into this. Welcome to The Explainer. Today, we are looking at something that has literally reshaped how artificial intelligence solves complex problems over the last couple of years. We're going to unpack the fascinating mechanics of AI reasoning models. More specifically, we're focusing on how developers are now building in controls that dictate exactly how much effort an AI puts into answering your prompts.
It's a pretty compelling question, isn't it? Can we actually control how hard an AI thinks? Because right now, every single time you send a prompt, there's this critical trade-off happening totally behind the scenes. We're constantly balancing the AI's thinking time against computing costs and the ultimate accuracy of the answer we get back. If you want a better, more accurate answer to a really tough math or coding problem, you need the AI to think harder. But thinking harder costs more money and it takes way more time. So how do we, and the developers building these tools, actually manage that balance?
Here's how we're going to break it all down in this explainer. First, we'll cover what AI reasoning actually is. Second, we'll expose the think token illusion. Then, we'll look at training versus inference scaling. After that, we'll see how to actually build an effort dial, explore a few real-world recipes, and finally, peer into the future of automated AI thinking.
All right, Section 1. What is AI reasoning? Let's get into the mechanics of step-by-step logic.
So what do we actually mean when we say a massive language model is reasoning? Well, with a conventional model, you ask a question and boom, it immediately spits out an answer. It's super fast, sure, but if the problem is highly complex, it might just totally guess wrong. Now, a reasoning model works completely differently. Instead of jumping straight to the final output, it generates an intermediate step-by-step trace. It works through the logic, step 1, step 2, step 3, before finally delivering the answer. It's literally just like a student showing their work on a math test.
But how on earth does a model learn to do this? It learns through something called RLVR, or reinforcement learning with verifiable rewards. I know, it sounds super technical, but the core concept is beautifully simple. When you're training the AI on math or coding, the system gives the AI a binary reward, a 1 if the final answer is perfectly correct and a 0 if it's wrong. But here's the absolute kicker. That reward is based strictly on the final correct answer, not the intermediate steps. The AI figures out entirely on its own that writing out a step-by-step trace is the best way to get to that correct final answer and secure that positive reward.
And because the AI is just so incredibly motivated by that final reward, you get these wild aha moments during training. The AI will be generating its reasoning trace, suddenly realize its logic is flawed, and actually write out, wait, I made a mistake. It then backtracks, fixes its own error, and keeps going to get the right answer. That kind of self-correction, that is the true hallmark of AI reasoning.
Moving right along to Section 2, the think token illusion. This is all about what you see versus what the AI actually does.
If you've played around with any of these modern reasoning chatbots, you've definitely seen those little think tags pop up on your screen before the answer arrives. It totally looks like the AI is entering some intense, special cognitive mode, right? Well, I have to break the illusion here. Those tags are purely cosmetic UI wrappers. They absolutely do not make the model reason, and they don't make it think better. They are simply formatting tools used by the system to separate the internal reasoning trace from the final answer, basically so the interface can neatly fold it up and hide it from you. The real intelligence is in the model's training, not in those little brackets.
Section 3, training versus inference scaling. Let's talk about the two main knobs of AI power.
Think of it like this. Training scaling is essentially buying a car with a massive V8 engine. You are building a fundamentally bigger model with way more parameters, feeding it a ton of data, and using supercomputers for months to train it. Inference scaling, on the other hand, is like taking whatever engine you already have and just giving it way more time and fuel to reach its destination. You're keeping the model size completely fixed, but you are allowing it to generate more tokens, more of those intermediate reasoning steps during the actual usage phase. Both methods improve the final answer, but inference scaling is what you are actually interacting with when you ask a model to think harder.
That brings us to Section 4, controlling AI effort levels. How do we actually build the effort dial?
Let's see how this dial gets built into the training pipeline. It usually happens in 2 steps. Step 1 is supervised fine-tuning. This is where the model is shown examples of both really long, detailed thinking and really short, immediate answers. But step 2 is where the magic happens. Reinforcement learning using token penalties. Developers literally tie a penalty to whatever effort level you request. So if you select low effort, the AI gets hit with a high penalty for every single word it generates. That effectively teaches the AI to be brief and skip the deep reasoning. But if you select high effort, the token penalty is practically 0, which gives the AI a massive budget to spend on tokens and think through the problem as thoroughly as it wants to.
And as you might guess, Turning up that effort dial has highly predictable results. When you move from low to medium to high effort, you get a direct corresponding jump in performance. The accuracy absolutely goes up. But you also see a huge spike in API cost because the model is spitting out way more tokens. The catch here, though, is that the performance gains eventually start to flatten out. You hit diminishing returns at those highest, most expensive settings. Throwing endless compute at a simple problem just won't make the answer any more correct once it's already solved.
All right, Section 5, Real-World Reasoning Recipes. Let's see how today's flagship models actually implement this kind of control.
It is honestly fascinating to see how different companies are tackling this exact same challenge. DeepSeek V4 goes a really unique route. They actually distill separate, distinct specialists for different effort levels right into one model. Nematron 3 Ultra does something totally different. They train the model by randomly cutting off its token budget halfway through. That forces it to learn how to quickly wrap up its logic and spit out an answer when it hits a hard limit. Then you've got Qwen 3 using what they call thinking mode fusion, seamlessly blending thinking and non-thinking examples so it can toggle between the two based on your instructions. Without getting too bogged down in the technical weeds here, the big takeaway is that there's no single right way to build this effort dial just yet. The whole industry is rapidly experimenting. Which leads us to our final part, Section 6, the future of AI thinking. We're moving towards automatic effort selection.
So right now, as we've seen, controlling AI effort is mostly a manual thing. You have to explicitly tell the model, through a system prompt or a drop-down menu, whether to use low or high effort. But the absolute holy grail for the industry right now is automatic effort selection. You really shouldn't have to guess how hard the AI needs to think. In the near future, we're going to rely on automated agent routers. These smart little routers will sit right between you and the AI, instantly evaluating how complex your prompt is and dynamically balancing the compute cost and latency entirely behind the scenes. You won't even have to touch a dial.
Which leaves us with this one final, really provocative thought. As these automated routers get smarter and smarter, will AI soon decide entirely for itself how hard to think about your prompt, automatically optimizing your budget and time? Or, as focused learners and power users, are you going to demand to stay in the driver's seat, keeping strict control over the reasoning depth for your own specific workflows? It is a massive shift in how we interact with technology, going from just asking for answers to managing the actual cognitive effort of the machine itself. Thank you so much for joining me on this explainer. I hope this deep dive gave you a much clearer picture of what's really happening under the hood. Keep learning, and I'll catch you next time.